Welcome back to Westgate Beyond the Collapse. Today, in part 2 of this series, we explore the early construction phase of the Westgate Bridge, following the early investigative and design works concluding mid-1968. This is where the abstract concept of the Yarra River crossing became something tangible. A time of innovation, coordination, and problem-solving on an unprecedented scale in order to target the bridge's original opening date of late 1970 or early 1971. The foundation of the bridge and completion of Contract F, comprising the piles, footings, and piers, which are the bridge substructure, was the first major engineering challenge. The Birrarung's geology at its mouth presented a mixture of silt, clay, sand, all of which overlaid volcanic rock. Engineers needed to use a foundation system that could penetrate unstable upper layers and anchor firmly into the bedrock below. The foundation solution selected was a series of cylindrical piles driven into the underlying strata and filled with reinforced concrete, their length varying at different locations, with some being as deep as 63 metres below ground level. These were driven into nearby ground and the bed of the Birrarung using diesel hammers, then cleaned out and filled with reinforcement cages and concrete. These piles were then capped with further reinforced concrete to provide a stable platform for the bridge's towering piers. This method was meticulously planned, with bores and testing of samples guiding every step. As the pile foundations and their footings were being constructed, the John Holland Company established casting yards on either side of the river and began the stringently coordinated production of the bridge's concrete viaduct components to action the elements under Contract C of the project. These included over 1,250 primary precast units, such as the core spine beams of the viaduct, along with the cantilever wings, which made up the total width of each approach, each element being post-tensioned to handle the immense forces it would endure during operation. In addition to these primary components were further prefabricated modular slabs, which would later have reinforced concrete poured over them to create the structure immediately below the finished asphalt surface trafficked by vehicles. Steam curing of these components ensured the concrete achieved maximum strength in a timely manner, while the precision jigs allowed for consistent production to within required tolerances. By the project's end, these production yards had used over 46,000 tonnes of concrete, a testament to the scale and complexity of this element of work within the project. Similarly, the level of quality in relation to this contract, as part of project delivery, was excellent, with only 2 of the viaduct core spine units falling short of the required tolerances and being rejected across the full program. The assembly of these pre-tensioned viaduct elements required equally innovative techniques. A moving gantry and crane system carefully positioned each concrete segment, aligning them to within millimetre precision. Temporary supports stabilised the previous span section, as the post-tensioning cables were threaded through the ducts to secure the new structure being constructed within the gantry assembly. Segments could weigh as much as 125 tonnes, depending on their web thickness and position within the post-tension span assembly. Their installation required seamless coordination between the casting yards, transport teams, and on-site crew in order to meet quality requirements and remain on program. As a side note, construction of the Westgate Bridge also reshaped the landscape around the bridge itself. At Fisherman's Bend, a former garbage dump and RAAF Air Force Base were transformed into an industrial hub along with recreational facilities, such as the Westgate Park. You know, that one from social media with the pink lake? Roads were realigned, many utilities relocated, and areas like the former Spotswood Golf Course, now called the Westgate Golf Course, were reconfigured and improved to accommodate the project and its footprint. These were some of the side benefits of the new roadway itself coming into fruition, and this is often the case with many major projects. where they provide ample opportunity to go beyond their core scope and promote wider benefits to those nearby and impacted by their construction. But getting back to the bridge construction, of course, the only remaining scope outside of contracts F and C, the two parts awarded to the John Holland Company, was the remaining steel bridge segments awarded to World Services and Construction as part of Contract S. This work also commenced shortly after award, with steel being ordered from BHP weeks after contracts were signed, and discussions on the requirements of the grade of steel being agreed by all parties. It seems, however, compared to the two other contracts awarded, World Services struggled to keep up with the intended project program. Key reasons being due to strikes and several disputes between the various unions within their workforce. They had managed to assemble and erect in half-box form the span between piers 14 and 15, located on the eastern side of the river. These two half-box forms weren't fully bolted together, however, and when being erected, had shown issues with deformation taking place. They were able to jack up one end to achieve alignment, but then cause some further damage, which later required fixing. It was around this time that it was agreed that program delays wouldn't be tolerated anymore by the Lower Yarra Crossing Authority, and they actioned clauses within the contract permitting them to take work off World Services, and they opted to award this work to the John Holland Company under a new contract referred to as Contract E, where World Services would still assemble the half boxes at ground level, but erection and bolting of the assembled half box forms at elevation would be performed by John Holland. Contract E was dated July 1970, but informal agreements meant that John Holland had already taken over responsibility mid-March of 1970 through a letter of understanding. Only months after agreement for John Holland to take over elements of World Services scope, the Milford Haven Bridge, the same one mentioned earlier as being designed by Freeman Fox and Partners, collapsed during its own construction. This incident overseas killed 4 workers and injured a further 5. Naturally, this set panic and concern amongst the Westgate Bridge workforce, as well as the Lower Yarra Crossing Authority, all of whom had questions in need of response. This resulted in G. Monsell and Partners in London commencing a full and independent review of the Westgate Bridge's design against the cause of the Milford Haven bridges. Sadly, this report and its findings would only become available after the Westgate Bridge had collapsed. The report did show, however, that the mode of failure differed between the two structures, as both also used different erection methods. The Milford Haven Bridge was pushed outwards as it was assembled, whereas the Westgate Bridge was assembled in half lengths, which were raised into position and intended to be joined at height. It seems that whilst awaiting the report on the Milford Haven Bridge collapse, along with the independent review of the Westgate Bridge's design taking place, pressure was still placed on progressing construction of the Westgate Bridge. This pressure most likely passed on to World Services and John Holland, now working in parallel with one another to close the gap between the almost completed concrete viaduct approaches. The eastern span was completed between piers 14 and 15, with the tension now turning to the opposite bank of the river. The opposing steel segment between piers 10 and 11 on the western side had been assembled at ground level and was now ready for erection to rolling beam height. The jacking procedure commenced mid-May 1970, with both half-box forms reaching rolling height by late August. It was at this point that all parties involved once again observed similar issues to those which had plagued the opposing span at piers 14 and 15 on the eastern approach, with significant deformation and misalignment of the two halves and limited options available on how to resolve them whilst maintaining progress against project program. So now we're at late August 1970, with the concrete viaducts nearing completion and attention, along with significant pressure, turned towards progressing the completion of the steel spans of the design. But the project was about to face its darkest hour, where poor understanding of structural behaviour, along with equally poor oversight and decision-making, resulted in one of Australia's worst industrial accidents on record. In Part 3, we'll examine the events from this point onwards, leading to the tragic collapse of the Westgate Bridge, the loss of 35 lives, and lessons learnt from that fateful day. I'm Paul Michael Angus. Thanks again for watching.